All right, so we're going to talk a little bit about sniffers here, and um, one of the things that we'll get into is some of the different tools that we like to use in the business. And um, I have a few friends that currently are at the expert level of the network defense, and um, they do a lot of really neat stuff. And having done some prototypes in the past where you can manipulate or intercept, specifically intercept some traffic and then be able to go through and manipulate it. It's pretty cool, pretty cool. And really, in order to be able to do some of that, you need to have a good understanding of uh, what a sniffer is. And for our purposes, what is a sniffer? What do you guys want, or what do you guys think a sniffer is? Anybody want to try to take a snap at it?
A
Anybody?
device or program that listens to the traffic and logs it.
Okay, that's beautiful. Thank you, Dwayne. All right, so for our purposes here, we're going to go through and talk a little bit about some of the things that um, are near and dear to our heart. One of them is, how does host-to-host communication happen? And when that starts to transpire, we need to have a reliable understanding of the OSI model and how that OSI model maps to the TCP/IP stack. And for our purposes here, what I'm going to do is I'll go through and actually uh, draw up here real quick. If you guys don't mind, I'll just put some boxes up here, kind of like this right here. Just stand by for 1 second. 4, 5, 6, and we'll put number 7 up here. All right, Chris, do you remember how we remember what those are for the OSI model?
Yeah, it's oh man, I just had it. It's all people seem to need data processing.
That's it, man. See, hopefully you'll be sipping on gin and juice somewhere in the Caribbean someday, and somebody will ask you, "Hey, do you know where what the OSI model is?" And you'll be like, "Yeah, I know, man." No, really. Hopefully nobody asks you anything about that. But so again, this is the correlation here. The stack would be, here's the TCP model, the TCP/IP model right here. And if we go over here and just say the OSI, and how do these relate? Well, they're pretty similar. It's just you're putting different lipstick on the pig. So for us looking here, the 7 to 5, so all people seem, right? This is the application layer. This is the presentation. This is the session. And what I would recommend is that if you don't have a good understanding of this, go out to the website and check it out. There's a pretty good video on that. And then over here, this correlates on this side to the TCP/IP model of the application layer, which is good. That's what we want. Transport is equal to transport. So here we have all people seem to, and that's layer 4. And then over here, the same thing. So it's easy to remember that one, right? So this is the transport. So these are two different models that you will see on your exam. Now, here's where it gets a little goofy, and it may be easier for you to remember one over the other. This one over here is actually the internet layer in the TCP/IP model. which is okay. That makes sense to me, right? But if you think about it, um, well, yeah, maybe that is a better way to call the network layer, or a better thing to call the network layer, right? So network is equal to internet. And then these last two here, we group them as a data link and physical. So here is 2 and 1, and the network address and network access is specifically what we call this layer over here. And this is also known as the DoD model. So not only do you need to be aware of what the OSI is, because that's usually in our vendor relationships that we have. I was in a meeting today with a pretty significant vendor, and just like I said, I count on my fingers. Well, I'm guilty of it. I did it today. That they started talking about one of the layers, and at this point I know what they are, but still, it's just kind of how you have one of those funny little moments in your head that you think, oh yeah, hey, I can go ahead and do this. And so I was doing all people seem to need data processing. We started talking about TCP/IP stack, and but the TCP/IP model maps to the older OSI model with 7 layers over on the left-hand side. So most applications actually use the TCP/IP suite for host-to-host data communication. So when we talk about host-to-host data communication, usually in some sort of normal operations, and that is arbitrary. The application layer is what is called encapsulated, and that's kind of neat how that works. If you've never seen that, we can maybe do that another time. But again, I would encourage you to go and take a look at some of the other videos, whether it's some of the videos that we have or some of the other videos that are out there, because there's a lot of good stuff out there for encapsulation. And essentially, as it moves down the stack, usually as the data moves down the stack, so 7 to 1, each layer appends to the datagram and encapsulates it, and then it comes across the line to, whoa, I'm zooming out here. Whoa, that was cool. Let me see here. Okay. All right, that was cool. So the way that works is, again, it goes down the stack like this, and I think that I can actually got an arrow. Ooh, look at that, an arrow. And then here, and then it goes up. Okay. Over here, this is encapsulation, and this is decapsulation. And I'm not going to do a lesson on an hour of how this works. It's just as it moves down the stack, 7 to 1, or in TCP model down that stack, and then it gets added, and then it pushes across the wire, and then as it gets pushed across the wire to the receiver here, it decapsulates it as it brings it back to the human layer, the application layer. So that's kind of how the host-to-host communication works. And when we talk about sniffers here, it's kind of neat because we can get into a whole bunch of different types of sniffing of data. And there's a lot of different tools that are out there that we can utilize that at the expert level will give us a great idea of specifically what is interesting to look at. So there's a few different things that we need to know, and they're shown up on the screen right here. First is we really need to know what this thing called ARP is. Anybody familiar with ARP? and why specifically it would be important for us? Okay. Well, it stands for Address Resolution Protocol, and really, ARP is fantastic because um, it is a form of active sniffing. And what we can do with ARP is it allows the network to translate IP addresses to MAC addresses. So we have the IP and we're looking for the MAC. Now, RARP or RARP is the reverse Avidab of that. It would be um, the you have the MAC address and you're looking for the IP address, so you send out a RARP, a reverse address resolution protocol. Um, so Sniffer works by capturing packets not destined for the system's MAC address. So whatever you have, whenever if things are not supposed to come to you, if you're running a sniffer on your machine, you can actually bring in everything else that's on the network onto your machine and take a peek at all the traffic. So I know this sounds kind of phallic, but that's called promiscuous mode. And when you turn your NIC, your network interface card, into promiscuous mode, you can normally what we usually will do is that, our NICs are um, um, only able to read and respond to traffic that's sent directly to us. But when we change our NIC to promiscuous mode, it's able to read all the traffic and sends it to the sniffer for processing. So we have two different types here, and you can see up here on the screen there's a passive sniff and an active sniff. So passive is usually when you're just listening and capturing traffic. And usually it's useful whenever the network is connected by hubs or repeaters or anything that actually just replicates stuff on the network. Active sniffing usually will involve launching an ARP and spoofing or doing some sort of flood, like a traffic flood attack, against the switch in order to capture or force specific responses. So it'll try to give information um, based off of elicitation of specific data that's going across the network. So just like the specific names indicate here, passive and active, um, which one of these two do you think would be a little bit more detected onto well, not a little bit. Which one do you think would put up a siren on your network if somebody was doing it?
Active.
Yeah, absolutely. Active sniffing would probably start to send some sort of intrusion detection device. Um, it would start making it look like it's going crazy. And it's quite interesting to see some of this on the line. If you've never played with some of the tools, we'll go through that here in a second. Um, so what we can have is we have a lot of different things. So usually, if you have a switch that's out there, um, the switch will actually try to look at any of the data that's coming through, and they will try to forward it out based on MAC addresses. So it has this MAC table of all the systems and port numbers and who's connected to who. And specifically, what the MAC addresses do for the switch, it can actually allow us to um, segment the network traffic off and send only the correct stuff to a specific MAC address. So it's kind of neat the way that switching kind of helps to uh, sniff and monitor. But we can also use this thing called a span port that's down here at the bottom. And let me just show you here. Whoops, I didn't mean to cross it out. Uh, but the span port is kind of neat the way that this works. And let me just draw this real quick. So if you have, let's say that this is your typical router that we have. I'm going to try to draw it here. And wow, these keep getting bigger and bigger. Let me just do this. So each one of these is this right here. Um, and then let's just say it's an 8-port router. Okay. Um, so each one of these, then we could, so 1, 2, 3, 4, 5, 6, 7, 8. And then each one of these, we would have a cable coming out that would go somewhere else, right? So cable comes out. So span port allows us to set up an IDS. So let me just draw that real quick. Here, if we set up an IDS, what we do is we take these 7 ports right here, and we tell the device to replicate all traffic to the 8th port. So 1 through 7 here would then come over to 8, and then this would be called the span port because it spans all the different ports that are currently plugged in, and it's a monitoring port that becomes available. And usually what we do in the span port is we hook in an intrusion detection system. So that's where an IDS would be right here on the span port. Now, it's pretty cool the way that some of um, these IDSs work. And I remember when I was at a large government contractor, we actually had a product that did this right here. It actually would lawfully intercept and then take it out of span port, and through an FPGA, which you can look that up if you don't know what that is, it would actually take the data and then push it out another plane with little to no latency as it monitored and looked at specific things that were coming across the wire. Um, so we could actually have some fun and do a couple things. And for our purposes, yeah, what I would say is if you're not already signed in to the learning management system, then hit me up and we'll hook you up with some of the labs that we have. Um, but wiretapping and lawful intercept, um, I'd say if I was you and I was preparing for this right here, the exam, I would definitely know um, the difference between these two. Whoops, shoot, sorry. I would definitely know the difference between passive and active sniffing. Just know basically what a lawful intercept is and why we want to monitor ISIS and really tap everybody's cell phones, and what the Patriot Act really overwhelmingly does now. Um, what a wiretap is and what's the difference between these two. Really, there's not much. How sniffers work, definitely you need to know that. How would an attacker um, try to get on a switch? That's a good question right there. Usually, it would be some sort of um, limitation of a switch, and typically it would be trying to manipulate ARP. So ARP poisoning is a technique that's used to attack an Ethernet network, and usually you can sniff frames that they're coming across a switch LAN with ARP poisoning. So usually we can send a fake, or um, some people say spoof, an ARP message to a LAN. And then when we do that, the frames contain a false MAC address that confuses the network and then starts to poison um, specifically. Now, how could you do that? You're like, well, I don't know, man. I don't know about that. Well, there's a bunch of different ways, and we're about to show you one of them right now.